Cosine, oh, is this? Ooh. Okay, so cosine, this is just 0 by definition. You just look at your, we're going to get down. We're done. Okay? Questions online, peeps? This is so awkward. Okay, time's up. Let's move forward. I've got here the other. Nice. So question number 5 is cosine of theta equals 1. Tell me every place where that is true. What am I going to do?
I forgot. I remember how to write it. I forget what you used.
Okay, so quickly, the graph looks like this. Does that look okay and familiar?
Yeah.
Okay, if that's the case, where is it 1?
At the top. Every time it goes back up.
Okay, but where, what angle is that at?
360, I think.
Okay, but we're using radians, so we'd say at 2 pi.
Oh yeah.
And we'd say at 0. Where's the next place it's going to appear?
4 pi.
Where?
2 pi.
Okay, after 2 pi. It's going to go down and back up, right?
Yeah.
When it gets back, when would it get back to the stop?
Another 2 pi.
Which would be 2 pi plus 2 pi, which is?
4 pi.
4 pi. When would the next place would it appear?
6 pi.
Nice. By the way, it would go this way too, wouldn't it?
Yeah.
And so what else is over here?
Negative 2 pi.
Negative 2 pi. And then we realize, oh no, I don't want to do it that way. So I got to come up with a format by which I can write the answer so I don't have to write an infinite number of choices. What's the format? Do you remember?
It's like theta equals. Is it pi plus?
You have to pick one place where it's true.
0.
0 works. Plus, how often does it repeat?
Every 2 pi.
Every 2 pi, and then I throw an n on there. And then I say that n is going to be where n is equal to ... negative 1, 0, 1, 2, ...
Is it always just those numbers? Like maybe one?
It's always going to be find me a correct place plus however long till it repeats n. Right? Because really all I'm doing is I'm saying, what if I put a 1 in here? I get 2 pi. If I put a 2 in here, I get 4 pi. If I put a negative 1 in here, I get negative 2 pi. It just gives me a way to write that answer.
When it says like where n, like that's always going to be the 1.
Yeah, it's always, well, okay. So the correct answer for that is no. You could actually use other letters if you wanted to. Other numbers you wanted to. I would stay away from that. Let's not freelance. That make sense? The problem with freelancing is you get yourself all kinds of trouble. This n has meaning. It means it's natural numbers. And so you could make an argument, well, what couldn't I write like this? Where n is equal to ... negative 2, 0, 2, 4, 6, ... Right? Because now I'm just plugging in 2's. 2 pi, 4 pi, 0 pi, all works. And it feels like that would work fine. And it turns out in this case it would. But if you wrote it like this, I'd have to take away your points. Because it doesn't show the pattern that these are all even natural numbers. And I don't even want to talk about the stupid rules. Hey, just do it the other way. And you know, if you're kind of confused and you think you can work it out a different way, do it. I'll probably let you have it. But in general, it's just ... negative 1, 0, 1, 2. Make sure you put a negative 1 on there. You start with 1. Natural numbers mean something different. Which is rude. Back in 8th grade, they made you learn what a natural number is. Do you know what a natural number is? I hardly know either. I have to look it up every time. I know. It's handy, I'm sure, somehow.
What's it called?
Natural numbers. Then we do natural numbers, integers, and rational and irrational. We still use rational and irrational because that's important to us. Okay, so jump on number 6. Let's go. This time I'm going to torture some online kid. Be ready. We know it's true at pi. Where else would it be true? Emily?
Yeah, I'm sorry, what's next?
Where else would it be true? Put the cell phone down.
No, I'm here.
Uh-huh.
At pi and 3 pi.
Okay, where else would it be true?
5 pi?
All right. Could I go this way?
Yes.
What would it be over there?
Negative pi?
Negative pi. Okay, so now I got to write theta equals. Tell me one place it's true.
Pi.
Plus, how often until it repeats?
2 pi?
N, where n is equal to what?
2? Or no. Pi plus 3 pi?
What?
Wait, I don't know, I'm sorry.
We've had a long discussion about it's always going to be that.
Yeah.
You where everything?
Yes. Although, again, yeah, no, I'll take away that. I'll take the point away. I'll be mean about the where. Probably won't, but don't quote me on that later. Ms. Manship, you caught up on this? All right, that's all the internet she gets today. Emily! All right.
Yeah?
How bad is your internet connection?
It's not.
What are you doing instead of learning?
Nothing.
Sure. All right, fine. All right. Okay, so let's try to do number 7 on your own. I haven't explained how to do it, but I think you can do it without me talking to you too much. Try number 7.
Back down, cross through the 8 pi, down to -1, and then back up to 9
Okay, so 8 pi, hold on, I'm catching up to you. 7 pi, broken graph, 8 pi, 9 pi, right? And you said we're going to start at 8 pi, we start at 1?
No, we start at 7 pi.
Oh, and where are we starting at 1 then? Where are we starting at 7 pi?
Like, on the x-axis.
Why? Where does cosine start?
Cosines. I have no idea.
Okay, turn back 1 whole page.
Okay.
I made you graph it out in gory detail. Where does cosine start? Where is it at 0?
It starts at 1.
Starts at 1. By the way, it's one of the things you're supposed to memorize by now.
Okay.
Now, that's 1 at 0, but 0 is way the heck over here somewhere, right?
Yeah.
But 0 is the same as what?
7 pi?
Why? How often does this thing repeat?
What?
How often does this thing repeat?
It repeats every 1. Every pi.
All right, I'm backing up. So this is what the cosine curve looks like. So how far does it go before it repeats?
1.
Well, when it gets to 1, it has repeated. But how far does it have to go this way to repeat?
Every 2 pi.
Every 2 pi. So it had the exact same graph where?
At like 7 or 8 pi.
8 pi. Because 4 pi would be the same, 6 pi would be the same, and 8 pi would be the same. Agreed?
Yeah.
So where are we going to be at 8 pi?
1.
At 1. 8 pi, we're going to be at 1. Now, 1 pi over, we're at the bottom, right?
Yes.
So, 1 pi over, I'm going to be at the bottom. So far, so good?
Yeah, that makes sense.
Now, how do I finish my graph? Because I want to start at 7 pi.
You go down to -1 by 7 pi.
Okay, what are we going to call this graph? Because we're going to see this lots, and I just want to say it's a shape. I used to call it girly hair, but that doesn't apply anymore.
I have no idea.
All right, fine. All right, no fun for you. All right, is that good, everybody? Mr. Combs, you good?
Probably good.
All right, excellent. Okay, so then 5-8 is just practicing and playing. So I'm going to start writing answers up here. You're going to start checking your answers. When you have a question, you're going to say, Mr. Resney, I do not know how to do problem number whatever, and we're going to do it together. Does that make sense, Mr. Combs?
Yeah.
You feeling okay, sir?
Kind of. I don't know. Yeah.
Yeah. All right. Go ahead and start doing. Go ahead and start doing 5-8.